Hello children, welcome to the mathematics class. Today's topic is on application of integrals, that is the area under the curve, and the differential equations. To start with, we first revise the synopsis and then we go to the problems. So in this video, we go with the synopsis first. Area under the curve. Whenever a function y is equals to f of x is defined in an interval a comma b closed interval, area under the curve equation, the curve graph may be like this: between x equals a to x equals b, starting from x equals a to x equals b, area under this particular curve is given by the formula integral a to b f of x dx, where y is a dependent variable, x is an independent variable. The same is with respect to y-axis when you take up. So area under the curve, x is equals to function of y, area under the curve with respect to y-axis is given by integral c to d g of y dy. Coming to the next one, area under the curve y is equals to f of h of x. Let me take up y is equals to h of x is a graph where it is starting from x equals a to x equals b. Some portion of the curve is positive, some portion of the curve may be negative. In such a case, we divide the total interval into parts. So x equals to c, for example, x equals to a to x equals to c, it is positive, and c to b, it is a negative. In such a case, we take it as a modulus value, so that it will be easy. While after calculation, you take modulus, gives us the numerical value. Integration from a to c modulus h of x dx, integral c to b modulus h of x dx gives us the original value. That means after evaluation of integral, take the modulus. Coming to next, area between the curves. And whenever you are given the two curves, y is equals to f of x and y equals to g of x, between x equals to a to x equals to b, area under the curve y equals to f of x minus area under the curve y equals to g of x. Area under the curve y is equals to f of x is nothing but this one, minus area under this curve, eliminate this particular portion, gives us area between the two curves, between the two ordinates x equals to a to x equals to b is given by integration a to b f of x dx minus g of x. Of course, here f of x is greater than or is equals to g of x for all x belongs to closed interval a comma b. If one curve crosses another curve, we take the modulus as like the previous one. Coming to the next one, suppose y equals f of x is the curve like this and y is equals to g of x curve like this one, and both of them x equals to a to x is equals to b. If you have a split the area, then we can split the area into two particular parts, a to c area under this curve and c to b area under this curve. So this portion separately we calculate and we add. That gives us the total area. Coming to next one, integral as a limit of a sum. I hope in the definite integrals we had a discussion about this one. There is a formula here. If f of x is a continuous function defined in the closed interval a comma b, limit n tends to infinity, sigma r equals to 0 to n minus 1 by n, function of r by n is equals to 0 to 1 f of x dx. And suppose there are certain formulae, of course, in the same the limit value, if you have limit n tends to infinity, sigma r running with 0 to kn 1 by n, function of r by n can be replaced by 0 to k, whatever be the n multiple, 0 to k, the function of r by n replaced by x into dx. This is how we define the function here. Coming to the next one, there are certain formulae which saves our time. If you remember the formulae, then memorize these formulae, then you can evaluate the problems and you can save your time here. And those timings are: area bounded by the curve y square is equals to 4ax and its latest rectum is given by 8a square by 3. And area of the ellipse x square by a square plus y square by b square equals to 1 is nothing but pi ab. And area between the curves y square equals 4ax and x square is equals 4ab, 4by is nothing but 16a square by 3. 16ab by 3, sorry. 16ab by 3. So y square is equals 4ax is a parabola looks like this one. And x square is equals to 4by parabola looks like this one. This is actually the area under between the curves is nothing but this one. So therefore this point to this point, find the point of intersection, area under this curve minus area under this curve we calculate. We simplify, you will be getting 16 AB by 3. Coming to the next one, area bounded by one of the curve, either y is equal sine AX or y is equals to cos AX with x axis in one arc. So therefore either sine x curve you take up like this one. Okay. Therefore each arc area is equals to 2 by a. This is 2 by a. Magnitude I am writing it. Even if you take up the cos also it looks like this one, the cos graph. So this area 2 by a, 2 by a and 2 by a, etc. This is about the area bounded by the trigonometric function and x-axis. Coming to the next differential equations. A few points we discuss of the differential equation. You know, an equation involving dependent variable, independent variable and the derivatives of dependent variable with respect to independent variable is called the differential equation. Okay, is called differential equation. As an example, x divided by dx plus y is equals to x cube, as there is a differential coefficient is there and therefore it is called differential equation. Coming to the degree and the ordinary types of the differential equation. There are two kinds of the differential equations which are ordinary and partial. Ordinary means ODE and partial differential equation PDE. If you consider an equation, a differential equation with all the derivatives are with reference to one independent variable, I say it is called ordinary differential equations. Suppose the derivatives or differential coefficients are existing with reference to one or more independent variables, then I say it is called one or more than one independent variable, then I say it is called PDE, partial differential equation. Coming to order and degree of the differential equation. The order of the highest order derivative which occurs in the differential equation is called order of the differential equation. Okay, let me take up the notation. Y1 means dy by dx, y2 means d square y by dx square, y3 means dq y by dx cube, etc. So now search for whether y1 existing, y2 existing, y3 existing and continuation like this one. The highest order of the differential coefficient which occurs in the differential equation is called order of the differential equation. The order of the highest derivative, which occurs in the differential equation is called order of the differential equation. Coming to the degree. What is meant by degree? Degree means the exponent or the power of the highest order derivative. Okay. So the power or the exponent of highest order derivative which occurs in the differential equation after it is made free from the radicals and expressed as in the form of a polynomial as far as derivatives is concerned is called degree of the differential equation. So first of all, there must not be any radical powers. That means no fractional powers should be existing it. And at the same time, no special functions should exist like sine inverse, e power of dy by dx, and cos of dy by dx, like that should not exist. That means it should be free from the radicals and special functions, and it should be like a polynomial as far as derivatives is concerned. Then in such a case, the power or the exponent of the highest order derivative is called the degree of the differential equation. Coming to, yes, the example here, 1 plus 3 times dy by dx whole power 1 by 3 is equal to 4 times dqy by dx cube. As there is a fraction here, by removing the fraction, cubing on both sides, you'll be getting as a polynomial in derivatives is concerned, and the highest order is 3, for which exponent is 3. And this is the degree of the differential equation, and third order is nothing but third order differential equation. Coming to solution of the first order, first degree differential equation. And there are different methods are there to find the solution of the differential equation. One of the method is nothing but variables separable. Whenever a differential equation is given f of x into dy or g of y into dx, we separate the variables, y variables on one side and x variables on one side, dependent variable and independent variable. Separately we rewrite and then integrate on both sides and add a constant. And thereby we find the solution. This method of doing the getting the solution of a differential equation is called a variable separable method. And of course, sometimes a differential equation may be given in this particular fashion, may be converted to variable separable form by assuming that ax plus by plus c is equal to some parameter, some other variable t, and thereby we can reduce it into variable separable form. Coming to homogeneous differential equation. A differential equation of the form dy by dx is equals to f of y by x is called homogeneous differential equation. While solving the homogeneous differential equation, there is a specific method is there. That is by assuming that y by x is equals to v. That means y is equals to vx. Dy by dx can be replaced by v plus x dv by dx. Thereby, this homogeneous differential equation can be converted to variable separable form, and thereby we can solve the differential equation. And the one more important differential equation is a linear differential equation. A differential equation of the type dy by dx plus py is equals to q is called linear differential equation in y, where q is not equal to 0, it is called non-homogeneous, and q is equal to 0 is called homogeneous linear differential equation. And thereby, where p is a function of x and q is a function of x. Of course, if this is a differential equation, integrating factor to get the solution of this differential equation to be calculated as e power integral p dx. Hope you know what is meant by integrating factor. A factor which helps us in getting a solution of the differential equation to make it a perfect square, perfect differential, that is said to be called integrating factor. Thereby, the solution of this differential equation is given by y into integrating factor equals to q multiplied by integrating factor dx plus constant, where p comma q are constants of functions of x only. Whereas the same thing, if you just interchange x and y variables, dependent to independent, independent to dependent, only the names are being changed here. X is a dependent variable, y is independent variable. This is actually the concept to get it. Same concept you can follow. Okay, and there are certain time saving results are there, which helps us in simplifying certain problems here. Equation of the family of lines passing through origin, equation of the family of straight lines passing through origin is given by y is equals to mx. And equation of the family of non-horizontal lines in a plane is given by ax plus by is equals to c, where a not equals to 0. And the equation of the family of non-vertical lines is ax plus by is equals to c, where b not equals to 0. And of course, x square plus y square is equals a square represents an equation of a circle with a different radii center at origin, a family of the circles. As a varies, you get the concentric circles. And these are another time-saving process. By eliminating parameter from the expression of the differential equation is formed, whose solution is a given expression. You will be given an expression with the parameters arbitrary constants as C1 and C2. To eliminate those two and to form a differential equation, you need to differentiate twice. Thereby, you can form a differential equation. That differential equation directly, you can get it this way. y2 minus a plus b multiplied by y1 plus a into b multiplied by y. As if a comma b are the roots of a quadratic equation, you can write down. The same way, this is an extension for the three numbers. y3 minus a plus b plus c and a b plus bc plus c into y1 minus abc into y equals 0. Same model when you have y is equal c1 x power m c2 x to the power of n, the differential equation can be written as x square y2 minus m plus n minus 1 x into y1 plus mn y is equal 0. And in the complex form, when y is equal to c1 a cos x, c1 cos ax plus c2 sin bx, nothing but harmonics solution of the differential equation y2 plus a square y is equals to 0. These about some of the important points which saves our time in solving differential equation. I hope you got the point here, and there are some other important results which you can solve the differential equation by converting the given differential equation to total derivatives. X, wherever you find x into dy, y into dx can be written in the form of differential of xy, and then you can integrating it on both sides. So that from here xy can be written as integral of x multiplied by dy plus y multiplied by dx, etc. Same way, x dy minus y dx by x square can be written as differential of y by x, and in the reverse order y dx minus x dy by y square equals to differential of y by x, and tan inverse of y by x is nothing but this one, etc. Right? Hope you understood the logics of all these total derivatives, and you can apply any number of functions like this one, I mean sine inverse, log xy, etc. Right? Now I would like to conclude these formulae in this video. In this next video, we continue with the problems related with area under the curve and differential equations. Thank you.